In the blue and white lab, you're trying to count the atoms of copper and of strontium. Copper will be easy because it will be an element, and you just say if you have 64 grams of it, that's 600 atoms. Pretty easy to do. The strontium will be more difficult because you won't have strontium as an element. You'll have it as a compound, such as maybe strontium sulfate, and it'll be in your bowl as this white powder, but when you weigh that, you're weighing both the strontium and the sulfate together. So there are a couple of different ways you can deal with that mathematically. Both of them involve the periodic table. Sulfate is defined on the periodic table as 1s and 4 O's. You can find the mass of that by adding up the individual atomic masses. 4 oxygens, 1 sulfur. You can find the atomic mass of strontium right here, rounded to 88. So one strategy is to count not individual atoms, but just count the whole thing. We can call this a molecule, and it has, instead of an atomic weight, a molecular weight. I can weigh the whole thing together, and maybe I can count how many strontium sulfates I get. If I knew I had 20 of these, clearly I have 20 strontium atoms and 20 sulfate ions. The alternative is to take these apart mathematically and say, okay, the mass is partly strontium and partly sulfate. So here are the atomic masses from the periodic table, and so I can add them all up together. 88, 32, 64, that's 184 grams total. And I think you can see that the strontium is a fraction of that, or a percentage of that. So proportional reasoning can tell me either the percentage or the fraction that is strontium in the total mass. So here's a hypothetical. Imagine if it was precisely 50% strontium, then if I weighed in my bowl, if I weighed 2.24 grams of strontium sulfate, I would know I have 1.12 grams of strontium, the element, in that sample. So clearly your numbers will not be 50% precisely, but conceptually this is how you could count how much actual strontium is in that bowl of strontium sulfate. An alternative approach is to use that total, that 184 grams we just calculated, and say that's the mass of the entire molecule. And then we can use the AM600 concept, but now you get not 600 atoms, you get 600 molecules in one molecular mass worth. You get 600 molecules. So this would be the proportion or the ratio. And then you can use proportional reasoning to say, in my bowl I don't have 184 grams, but if 600 molecules equals 184 grams, I can count the molecules of SrSO4 in the bowl, and then I know how many strontium atoms were in there.